Welcome back, ladies and gentlemen. You are listening to Mrs. Lewis's lesson for your notes. This is Chapter 3, Forces and Newton's Laws. So we just came off of Chapter 2, and we discussed and learned all about motion. So motion actually isn't going to go away. We're going to be using motion all throughout the year, in particular with Newton's laws and forces. So let's get started. For your Chapter 3 introduction, Forces and Newton's Laws, Chapter 3. And this is such a hot topic that the fire alarm just went off. So, under our introduction, there's 3 sections. Section 1 is forces. Make sure you're writing it down. Section 2, Newton's Laws of Motion. And Section 3, Using Newton's Laws. As always, write down the big idea of the chapter, and that is a force is a push or pull. So make sure you put big idea and then. A force is a push or pull. And the main ideas to each section. Section 1, unbalanced forces change motion. Section 2, Newton's laws of motion relate the change in an object's motion with the forces acting on it. Section 3, Newton's laws can be used to explain everyday events such as falling and collisions. As always, you don't need to write down the essential questions, but they are here for you if you ever did need them and wanted to practice. So since we're already here, let's go ahead and hop on to lesson 3.1, force. So what is force? Well, force is a push or a pull. And sometimes it's obvious and sometimes it's not. For example, when it's obvious, it's because something is changing motion. And although we can't, quote unquote, feel it, the floor is exerting, pushing, and pulling on our feet. Our first subtitle will be changing motion. A force can cause the motion of an object to change. So write that down. Let's just talk for a minute. If you have played billiards, pool, you know that you can force a ball at rest to roll into a pocket by striking it with another ball. The force of the moving ball causes the ball at rest to move in the direction of the force. Next subtitle, net force. So suppose 2 students standing side by side push a box with the same force and in the same direction. So in your notes, draw a student. Just going to draw a little person here, okay? And I'm going to draw another student, his pal. And he's not very happy about having to help his friend. And they are both going to be standing side by side. And they're going to be pushing on a box. They're both pushing with the same force and in the same direction. So I'm taking his force of 20 and I'm adding it to his force of 20, which gives me an equal force of 40. And let's say the box weighs 30 pounds. These forces are unbalanced, and the net force that acts on this box is found by adding these together so that the box will move this way. So now my box is going to be in the middle. You're going to be drawing a second drawing. So this is my box. Okay? And I have a happy person on this side because he gets to help Mrs. Lewis shove the box. He has very long arms. Okay? And his friend is standing on this side, and he's very happy because he also gets to help Mrs. Lewis push the box. So if they're both standing on opposite sides of a box and push on it with the same force, let's say he's pushing with 20 and he's pushing with 20, what's going to happen? Well, the first thing that's going to happen It's going to be a balanced force. Okay? A balanced force is when an object that are equal in size and in the opposite direction, and the net force on the box is going to be 0 because the two forces cancel each other out. Therefore, the box will not move. So as my 20 moves this way, and as my 20 moves this way, they cancel each other out, giving us a balanced force. Next subtitle, friction. So just talking for a second, suppose you give a skateboard a push with your hand or a friend. Does the skateboard keep moving with constant speed after it leaves your hand? The answer is no, and that's because of friction. Friction is the force that opposes the sliding motion of two surfaces that are touching each other. The force that will slow down that skateboard and bring it to a stop is friction. And the amount of friction between two surfaces depends on two factors. So this is what you need to write down under friction. There are two factors. One, the kinds of surfaces, and the force pressing the surfaces together. So you may not have heard of this term before, a microweld. Well, what is that? Well, it's a welding or sticking that occurs where the bumps touch each other. So the microwelds become a source of friction, and the larger the force pushing the two surfaces together is the stronger these microwelds will be, because more of the surface bumps will come into contact. So to move one surface over the other, a force must be applied to break the microwelds. I think pretty much everyone on the planet has opened up a plastic bottle of water or a plastic bottle of juice or a plastic bottle of milk, okay, soda, and there's that little indentation where you have that little ring. A lot of people like to chew on that little tiny ring that goes under the lid. And it's like a safety seal. That's how you know whether or not your stuff is safe to drink. Has anybody messed with it? Well, think of that as a microweld that you can see. So when you're pushing and pushing and pushing because you're trying to open up that milk so you can have it with your chocolate chip cookies, eventually, if you give it enough force, bam, it breaks the cap off from that little collar neck. That's the same type of concept as what you see on this diagram. And you know life wouldn't be the same without different kinds of friction. So the first kind is going to be called static. And I want you to start out by writing this down. It's a frictional force that prevents two surfaces from sliding past each other. So let's just look at our example for a minute. So suppose you have filled a cardboard box with books and you want to move it. Now it's too heavy to lift, so you start pushing on it, but it doesn't budge. If the box doesn't move, so the net force on the box is 0, another force that cancels your push must be acting on the box. That force is the friction due to the microwelds that have been formed between the bottom of the box and the floor. Our second type of friction, sliding. And writing down, it's the force that opposes the motion of two surfaces sliding past each other. What does that mean? Well, our example is here. You ask a friend to help you move the box. Pushing together, the box moves. And together, you and your friend have exerted enough force to break those microwelds between the floor and the bottom of the box. Remember a couple slides ago when we were talking about how if you pushed hard enough and exerted enough force on a bottle cap, it would finally come away from those major microwelds on the collar? Same thought process. So if you stop pushing, the box is going to quickly come to a stop. This is because as the box slides across the floor, another force, sliding friction, is still opposing the motion of the box. Okay, so our last friction is rolling. Not rolling in the deep, but rolling friction. And you need to write down it prevents wheels from slipping. So as a wheel rolls over a surface, static friction acts over the area where the wheel and the surface touch. This special case of static friction is sometimes called rolling friction. So when referring to tires on vehicles, the term traction is often used instead of friction. And I know you guys are all learning about traction, right? Because what are you doing right now? Scaring people while sitting behind the wheel of a car. So another word for traction would be rolling friction. And I would probably write traction in parentheses. All right, next subtitle, gravity. It's an attractive force between any two objects that depends on the masses of the objects and the distance between them. So let's take a picture or a look at the left, okay? So here we have two objects, and the distance between them, it's about the same as the distance between these two objects. However, the arrows indicate this has a greater pull for gravitational force than this one does. Why is that? Because the object with more mass is going to create a higher gravitational pull. So write that down. As the mass increases, so does gravitational force. The second side of that, it's not so much about mass, but we talk about how close are they together. So in this picture here, we have very little gravitational force, as is indicated by our arrows being very small, compared to here being very, very thick, where there is a high gravitational force. What's the difference? All the objects are the same. The only difference is these are closer together. So the closer objects move together, the greater the force will increase. You need to know all of this. The law of universal gravitation. Isaac Newton, Sir Isaac Newton, formulated the law of universal gravitation, which he published in 1687. This law can be written as the following equation. In this equation, G is a constant called the universal gravitational constant, and D is the distance between the two masses, mass 1, mass 2. The law of universal gravitation enables the force of gravity to be calculated between any two objects if their masses and the distance between them is known. So next subtitle, the gravitational field. A field is a region of space that has a physical quantity, such as force, at every point. Because objects do not have to be in contact, gravity is sometimes discussed as a field. This is important. Make sure you include it. Next bullet point, the strength of the gravitational field is 9.8 newtons per kilogram near Earth's surface and gets smaller as you move away from Earth. Write down this question. What is an object's weight? An object's weight is the gravitational force exerted on an object. Please write down the weight equation. So the table shows how various weights on Earth would be different on the moon and some of the planets. And if we take a look here, you can see that on Earth, if it's 75, then on the moon, that same object would be 12. And on Earth, if the object is 2,000, then here on the moon, it would be 333. You'll need to write down this problem to solve for weight. The problem is an elephant has a mass of 5,000 kilograms. What is the elephant's weight? And continue following that so that you will have an example in your notes, and we'll talk about it in class. That's it for today.